All right, today we're going to work with determining equations of tangent lines. How can we determine equations of tangent lines? Well, first off, we need to look at the idea of what do we mean by a tangent line. Okay, what is a tangent line? When we talk about a tangent line, what do we have with a tangent line? How do we draw a tangent line? Okay, you touch it at one point. That's exactly correct. You draw a line that touches at one point. So we are going to intersect the graph at exactly one point. But we're going to call this a local tangent line because if we extend our tangent line, we may intersect the graph at more than one point. But if we talk about a local idea, we're just talking about a small domain. So we're going to be talking about a domain from A to B. We're going to talk about a small domain because, once again, if we extend this graph, we extend this line throughout, we may intersect the graph at a second point. We just want to take a look at a very small area, and when we're talking about a small area, we want to look at a tangent line. Well, what we want to do is we want to draw a graph and determine the slope of the tangent line at an x value of 2. So if I take a look at my graph here, at an x value of 2, this takes me to this point right here. We want to determine the slope in the equation of a tangent line. And this is a lot easier for you to draw in because you can move your straight edge wherever you want to. It's a little bit more difficult for me to do it. We want to determine. We want to determine the equation of this tangent line. Well, when we're determining the equation of a tangent line, we need to do two things. We have a point slope equation. Our point slope equation will allow us to determine an equation of a line. An equation of a line if we know a point that the line contains and we know the slope of that line. So if we know the slope of that line and a point that we can contain, we can find the equation of the line. Well, my point that I'm dealing with here, my point is the point of tangency. Our point of tangency. Well, our point of tangency is where the line and the graph intersect. So here's my point of tangency. So we know that. Hopefully we can determine that. We know the x value is a value of 2. What's the y value going to be at that point of tangency? How'd you get it? Okay. We could follow over to the axis here. That would be one way. What if it's not easy? What else? How else can we find that point of tangency? Plug it in. Yeah, plug it in. Plug it in, plug it in. I can find my f value at 2, which is a value of 4. And once again, we can follow this over also, but What happens if we have 2.5 or 2.789418891587992? Tough to eyeball that. I used to be able to do that, not anymore. Old eyes. Well, if we take a look, for us to find the slope, our slope is defined just as delta y over delta x. That's how we determined our slope of a line, which is y2 minus y1 over x2 minus x1. The problem we run into is we only know one point. We don't have a second point here. We don't have a second point. We want to determine a slope of a line, but we only have one point. Well, let's take a look at some ideas that we've talked about before and some new ideas we've talked about with respect to limits. If I look at my function value at 3, my function value at 3. So if I would take my graph up to here, we can find a y value at 3. And my function value at 3 would be what, Brianna? 9. And what this gives us is this gives us 2 points. If I would draw a secant line between these 2 points, here would be our secant line between those 2 points. We can determine the slope of that line because we know 2 points. We have a value of 9 here. We want to say, to draw what is the slope of the, that should be a secant line, through the points 2, 4, and 3, and 9. Well, we can now utilize our idea because we know 2 points. We know 2 points. We can find the slope of this line by our delta y over delta x. y2 minus y1 over x2 minus x1. And we can determine the slope of that line. I have 9 minus 4 over 3 minus 2. So Quentin, what do we get for a slope?
Oh, 5.
5. We get a slope of 5. That's you. Well, let's take a look at x is equal to 2.5. If I take a look at x equals 2.5, I'm going to go up to my graph. And I got a point at 2.5. And I draw my line between these points right here. What we come up with is a line that's in between our tangent line and the other secant line that we drew in there. So once again, this should be a secant. The question is, what is our y value at 2.5? Our y value at 2.5 would be what, Justin? 6.25. 6.25. So we can now find the slope of this line by once again using my delta y over delta x. And Jack, we now get our slope to be equal to what?
4.5.
4.5. So if we take a look at what is occurring here, our first line, we had a slope of 5. Then we have a slope of 4.5. If we look at 2.3, so now we have 2.3. I go up to my graph. I have a point there in my graph. I could draw another tangent line. Change the color. And we get another line that we could throw in there. And we want to determine the slope of this new line we drew in there. Well, to find the slope of this line, we need to have 2 points once again. So we need to know what a y value is of 2.3. Our y value 2.3 is what, Grayson?
5.29.
5.29. So we want to find the slope. Y over delta y over delta x. Our slope now is what, Callie? 4.3. So our slope of this line now is 4.3. Let's get even closer at 2.1. If we go to 2.1, and then 2.01, we continue to get closer and closer and closer to our x value of 2. Go ahead and find your y value here. Find your y value, find your slope. Then if I have 2.01, find your y values, find your y values. Find your slopes. Check your answers with somebody around you. Mike, what do you get for your y value for the first one? Yeah, for the y value.
4.41.
And when we find our slope, what do you get for your slope? 4.1. When we have our x value 2.01, Sarah, what's our y value? And what do you get for a slope? So if I take a look what is occurring here, if I would try to draw a secant line from 2.01 to 2, if I would try to draw this secant line, would I be able to determine a difference by our own eyes, the difference between a secant line drawn from x equals 2.01 to 2 and a tangent line at x equals 2? Would we be able to see the difference? No, we wouldn't be able to see the difference. If we could put a magnifying glass here, we'd be able to see the difference. So if I take a look at what's happening to our slopes of our tangent lines, I started out with 5, went to 4.5, 4.3, 4.1, 4.01. What would you guess the slope of our tangent line to be there? What? 4. The value of 4. The value of 4. Now, if we take a look at what is occurring here, I'm starting with x equals 3. Then I'm going to x equals 2.5. Then x is equal to 2.3. Then x is equal to 2.1. Then x is equal to 2.01. How can we put this in terms into ideas that we have just discussed? Okay? And we're talking about holistic, what are we talking about? That's what limits. We're talking about limits. So we're taking a look at the idea of limits here. And as Mike said, we're taking a look at a limit as x approaches 2. Now in this direction, we went from 2.3 to 2.5, 2.1, 2.01. So we're approaching 2 from which direction? Yeah, from the right. We're approaching 2 from the right. And if we would use the same idea as approaching 2 from the left, that would come up with the same values. So we're approaching 2 from the right. But as we approach 2 from the right, we're coming down to the value of 4. Now the question is, what are we taking the limit of? What we've took a limit of up till now is the limit of functions. But we're really not taking a limit of just one function anymore like we've done. We're just not talking about x squared plus 2x plus 3 or x minus 3 over x plus 4. We're not talking about that. What we're taking a limit of, as x is getting closer and closer, we are taking the limit of delta y over delta x. So we're taking a limit of this, of our slope equation. How we determine our slope. Because as x got closer to the value of 2, our slope of our tangent line got closer to a value of 4. Because we did a delta y over delta x each time. After we found this x value, or had this x value as we were approaching the value 2, we found a y value. From this y value, we then took a look at delta y over delta x. With delta y over delta x, we then found a slope as x is approaching a value of 2. And we come down to the slope is equal to value 4. Well, let's take a look at what delta y and delta x was. We have f of 2 minus f of 1 over x2 minus x1. We are looking at the limit as x approaches, x2 minus x1 over x2 minus x1, but this x1 was the value that we are approaching. So as x got closer to this x1 value here, we had x2, f of x2 minus f of x1 over x2 minus x1, and we were subbing in for this x2. Well, with all the x's, we try to simplify things a little bit. So we can take a look at, this is the value of a. We're approaching a value a of f of x minus f of a over x minus a. And this is a tangent line at x equals this value of a. And there's two ways of dealing with slopes of tangent lines. Okay, an instantaneous rate change of a function instantaneous rate change of functions are tangent lines, and we're talking about slopes of tangent lines. Slopes of tangent lines. When we are in physics and we talk about a curved line, you had a curve. When we had acceleration, and we want to find an instantaneous velocity, we can take a look at the slope of the tangent line. We can use the ideas that we talked about here to be able to determine that slope of the tangent line. Now, this is what we talked about, delta y over delta x. We also have a second method of being able to calculate the slope of a tangent line by using what we called a difference quotient. And this is what we did in pre-calc. This is a pre-calc earlier in the year in this class. We call this a difference quotient. And that's the limit as h approaches 0 of f of a plus h minus f of a over h. Now, me personally, and this is just me personally, I like this idea a little bit better, because what that does is instills in my brain, I'm still looking at slopes of tangent lines. There are some that are easier to work with this. There are some that's easier to work with this function. And we'll look at both of these ideas as we go forward. I'm going to find the instantaneous rate change or the slope of the tangent line of the given function at x equals 2. So we could go through the process that we just went through with respect to plugging in and plugging in values of 2.5, 2.3, 2.1, 2.01. But you can see that was very, very cumbersome. It took a lot of effort. So let's take a look at what we have here. We have an A value of 2. So once again, please do not forget your limits. We have a limit as x is approaching a value of 2. And we'll work both of these methods here. We have f of x minus f of a, or f of x is given to us as x squared plus 3x minus 4 minus our f at a. Well, what is our f at a value a? Well, that we can clickety clack into our calculator. We have 2 squared plus 3 times 2 minus 4. Well, if I take 2 squared, it gives me 4. I'm subtracting 4 at the end. So those two cancel out, so I just have a value of 6. Over x minus 2. Now, what this is going to create each and every time is this is going to create a discontinuity that will be removable. So if I would combine my like terms on top, we have x squared plus 3x minus 10 over x minus 2. If I try to plug in a value 2, I would get 4 plus 6 minus 10. 0 on top, 2 minus 2, 0 on the bottom. That gives us that discontinuity, but that discontinuity, we will be able to remove this each and every time. Okay, I don't have to worry about a direction because I don't have a radical coming in here. But I can take a look at my, okay, we define coming in from the direction, well, we don't have any radicals or logarithms. We don't have any of that, but I do have our discontinuity that we'll be able to remove. So we factor, cancel, sub. So go ahead and factor, cancel, sub on top. Factors what, Grayson?
X plus 5 and x minus 2.
Factor, cancel, and then we could sub. We have a value of 7. So if we want to determine the equation of a tangent line, we now know our slope is a value of 7, and we have a point of tangency up here at 2 and 6. Our point of tangency, or pi. So we can determine our equation of our line. 7x minus 2 is equal to y minus 6. Determine that equation of the line. Very quickly, I would like to go through the second half of this. We have the limit as h approaches 0 of f at 2 plus h minus f at 2 all over h. So we have to evaluate our function in x, 2 plus h. Once again, please make sure you carry your limits through. Now what you'll see, the first method, you'll do a lot of factoring, canceling, and subbing. The second method, you'll have a lot of multiplication, expansion. But things will cancel then for you. So we have the limit as h approaches 0. Let's see, 2, 4. Plus 4h plus h squared plus 6 plus 3h minus a value of 10. Making negative 4 is minus 6. The 4, 6, and 10 will cancel out with the negative 10. We can combine our 4h and 3h to give us 7h. plus h squared over h. We can cancel out one of those h's and then apply our limit. Limit as h approaches 0, a 7 plus 0. We get the same value of 7. Once again, one way you factor, the other way you expand out. Okay, you have factoring, and then you have expansion. Okay, your homework for tonight, and we'll continue to work on this. This will be our process going forward, looking at slopes and tangent lines and the equations of tangent lines. Page 148, we have 5 to 8 and 31 to 36. You're just determining the equations of tangent lines. And once again, you can use either limit to be able to calculate your slope. Okay, I'm not going to pigeonhole you into one way or another. You choose which one that you want to do. Because like I said, there's people that have a preference one way or another. Okay, I tend to tilt towards this one here. There's a lot of people that will tilt towards this one. A lot of calc books will be focused on this one, and then this is your alternate definition. Okay, I sort of like the alternate definition first. So if you focus on this a little bit more, that's fine. You make a choice. You make a choice. You have two ways of being able to determine. Eventually, we'll have to go into this when we take a look at trig functions. Sine and cosine, we'll have to use the difference quotient when dealing with sine and cosine functions and trigonometric functions. All right, questions? All right, my time is done.